first workshop just started. I wanted to make it very interactive, especially because we're 6 people. So I think it would be a good idea for everybody to turn their cameras on, because then we have a discussion, make it interactive, and just look into all that what Rail has to offer. And I will share my screen. I will. Yes. So if there are any questions, just feel free to ask them right away. And let me first start with the topic. So I'm working in railways within the Netherlands, which is a complex situation with lots of different things. However, one thing still remains back, and that's computational design. We use a lot of human work to do all the work within timetabling within the Netherlands. So, but first start, and then that's the result of challenges within timetable engineering. So I will introduce you on that, but first, who am I? So I'm formerly a digital rail consultant within Royal Haskoning DHV. The railways within the Netherlands has a lot of different stakeholders, and we are doing advisory work, consultancy work on all the aspects of railways. And my role is mainly on testing and doing simulations on the yearly timetable presented by operators and infrastructure managers of railways. And I'm very curious then that this is who I am, but I'm really curious on who you are. So I have a Miro board ready, and I will send you this link in the chat. So I'm really curious on who you are. So please feel free to enter the Miro board and fill in your name and your role, possibly the company who you work for. Good to see you too, Ian. Is everybody, does it work out for people? If you don't want to, you don't have to. Does it work out also for you, Ian? Or not? All right, there is some comment from Ian. You can just move the post-it towards and fill in, but you can also just fill in the chat. That's also right. Let's go back to the presentation. So this is who you are, this is who I am, and then have the program. I start out with an introductory of railway timetabling. How does it work, especially within the Netherlands? and how does it's challenging on the mobile, that's true, I can imagine. But it's good to have you here nonetheless. What are applications? Then I would suggest, I'm very curious what you see as application for computational design within railways, because I'm more of a railway timetabling expert and less of a computational design expert. But then why is computational design does have a small a step and function currently within railway timetabling? I go into the challenges, and then again, interactive, again in Miro, what can be possible solutions to these challenges? And then a wrap up, and we have breaks in between. So, and again, if you have questions, feel free to answer them or set something in the chat. So the infrastructure of the Netherlands, the timetabling of the Netherlands, does everybody know what timetabling is? It's possibly first. So the timetable, when does your train leave? I think that's the basics of it. And when does a train leave? It starts with the infrastructure. So the entirety of the Netherlands you see here, you have in black just the normal railway infrastructure, in green in the high speed, in red you just have freight, and then in blue you have heritage lines which are not used. Both red and green and black are interchangeable. So as you can see, it's a complex network, but it's not that complex. I'm sure that you've seen more complex networks outside of railways, but it starts here. But then how is infrastructure set up? Mainly of three components. So first you have the basics, just railway construction, 2 irons and stones in between. But you have the electricity system or other type of powering systems, but in the Netherlands mostly you have the electricity system, the catenary systems, and you have signaling systems. And I think mainly for timetabling, the signaling systems are very important, and I will go into that now. I think in the Netherlands is currently a rather easy system, and it mainly consists of the entirety of infrastructure setting up in blocks, and each block provides the previous information to signals. And so if you're after a signal with your train, then the signal provides red, the signal before yellow, the signal before that green. And this system is happily provided by the United States to us, to the Netherlands, after World War II. So it's a very, very, very old system, but it works. Currently, we're doing an innovation. We're trying to have this information besides alongside the track within the train, and that's called ERTMS. Possibly you have heard of it, possibly not, but that's an innovation that is currently be done within railways signaling. Apart from the infrastructure, you have different rolling stock types, each with their impact on the timetable. And you have freight, international or high-speed travel, intercities, and sprinters. Main difference between intercities and sprinters is that sprinters stop at each station, and intercities go from intercities, so not between towns. And I'm curious, what do you think? And this is still rather easy, but what do you think? What is the impact on the timetable for each of these different rolling stock types? So if you have something of that within the chat, I'm really curious where your knowledge currently lies.
Sorry, can I just ask you to repeat the question, Gijsbert?
So what is the impact of each of these types? So, and the difference between each of their types on the timetable within a country, for example?
Oh, okay. Now that's more than meet the eyes, I think.
So, that's true. That's true. But I'm really, so frequency is a very big thing. So sprinters mostly have in the Netherlands have a larger frequency than international transport. Different priorities.
I would say freights can go faster. No, maybe not.
It's
Or
it can be because it necessarily don't have to stop at stations, passenger stations. Other thoughts on this?
yeah, Carlos, have a
True. But priorities are very difficult within the Netherlands, and I will get up to that later on. But it's not always the case that, for instance, international transport has priorities above intercities. What do you mean with that, Jonathan or Carlos?
Yeah, that was my point, that maybe the international or the intercity having more priority over sprinter or freight.
Yeah.
I just wondered about the length of each trains as well, because for passenger, I guess it's very much defined by the stations they're going to stop at. Well, if it's freight, don't have the same restrictions.
Yep.
And of course, the length can affect, well, quite a few things.
True.
Yeah.
True. So all kinds of thoughts can arise when asking these questions, and I think you get, very important points. Especially freight is more lengthy, so it can be 700 meters, a train of 700 meters within Europe. International transport has a lower frequency than intercities. Also, very important, intercities and sprinters have a less long track. They need to go, for instance, within the middle country towards the western part of the Netherlands is a shorter part than, for instance, freight that goes from the harbor of Rotterdam to deep into Germany, for example. So freight and international transport has much more dependencies in their timetable. So they are more likely to have delay, especially within Germany, which delay is more common. I last saw that in 40% of all trains running within Germany have actually delay. So that is very critical for timetable design. Within the Netherlands, this is different, but especially these freight and international trains have loads and loads of delay most of the time. So how to work around that? Also, this is an hourly pattern. So you see here in blue the sprinters, in green the intercities, in red you see freight, and there are currently no international transport within this graph. This is a rather complex graph, but it's also rather an easy graph. You see it's between Utrecht and Leiden, which are two cities within the Netherlands. Towards Leiden, it's a single track, so trains cannot pass each other on this single track. And from Utrecht towards Woerden, it's double track, so trains can pass each other. And you see in the dotted line, you see the planned timetable, and in the striped lines, it's the simulated timetable, and you see 1 hour. So you see the 11 and 12, and the point within the Netherlands is a very high requirement of timetable design is that every hour is the same. Dus apart from peak hours, this is a peak. This is not part of the peak hour, but we simulate it as it is a part of the peak hour. But this is you see here the peak. Yeah, then you see here the peak hour. But every hour is the same. So if a train leaves at 15, it was from Utrecht. It does that every hour of the day at 15 past. 1, past 2, past 3. So this is a requirement. And this makes a delay a difficult thing. So this is actually a lot of work for computers, but currently within the Netherlands, also a lot of work for just people doing and checking all of the different connections. And I think this is a lot more handwork than people think, because there are just not enough. Yeah, there are challenges which I will go into now. But you see that this is a 1 hour that repeats itself, but you also see that the first half hour is somewhat mirrored, or is actually mirrored to the last half hour, and also every quarter is also similar, as you can see. So if I draw lines here, do you have any questions of this graph? Can you understand? And you see on top of the graph, you see Utrecht and it goes to Leiden. So you see in time, trains travel towards Leiden, the green one, for example. All right, do you have any questions on this graph? The speed of trains, so the steeper the line, the higher the speed. The speed is set by the 3 infrastructure categories I just mentioned. So, for example, if you have a bend within railways, then trains cannot go as fast. If you have a single track as specified, you have here from Woerden to Leiden, you have a single track. So trains pass each other at stations where there are double tracks. But for example, if this is Alphen aan de Rijn, it's called, if a train leaves, it has delay, the other train must wait. So that's always the case. And I think currently a very big improvement of this would be that computational design is part of timetable design, which is currently not not that much. So how is a timetable created? This is I did my thesis on this a while back, but this is a more simpler version, and I will show you the entirety of the graph later on. It starts with long-term planning. So both the infrastructure manager within the Netherlands and the operator, so the people from ProRail, the people that manage the infrastructure, but also the people that are freight and passenger operators, they both provide their information and their requirements into a very in-depth timetabling system, request system, which has also been part of the Netherlands for 30 years now, I think. And that's long-term planning. So we're currently working on timetables of 2030 and even for 2040 already, dependent on the infrastructure that is then in place. And after this long-term planning, which is years beforehand, it goes to traffic management, which is more short-term planning. Short-term in this case can be months beforehand. And then in operation. So long-term planning, most timetables, as I just showed, like this one, is designed years beforehand and must be ready before operation in, I think, half a year before operation. So the design should be ready. This all in all, the timetable and the infrastructure, it is really into this graph, as you see here. So this is the long-term planning for 2022, this year, of the Netherlands, and it depicts each train per hour in corridors. So each color is a certain corridor, cities connected between each other. And as I just said, every hour is the same. So it's standardized. And you see that here. I have a more close-up of the entirety of the graph. And you see here from Dordrecht to Geldermalsen to smaller cities within the Netherlands, every train leaves there are 2 trains. You see 2 lines between Gorinchem and Geldermalsen, and you have 4 lines between Dordrecht and Gorinchem. And that depicts that every half an hour a train departs. And you see that, for instance, here, if you see my mouse, do you see my mouse? At 18, so 18 minutes past a certain hour, a train leaves. And because there are 2 lines, it's also 48 past. And that's every hour the same. So it departs 18 and arrives 44, and it goes past a single station. And this is more of a sprinter type. So it departs 3 over, goes to 5 stations, and then 28. But this is done for every year, and this is the long-term planning. And this is also translated in this kind of graph, which is the same also 50 years ago, and it's still made when are trains departing and arriving at the different stations. You have all kind of unknown stations in the left, but you see here, you see the different letters, which are a single timetable, and the numbers are one for the weekends or the evenings, which does have a different hourly timetable. And you can have this for every hour. So do you have any questions for this long-term planning? All right, then this is the same hourly pattern for Dordrecht Geldermalsen. So you see here, for example, it leaves at 3 minutes past 9. It leaves 18 minutes past 9. And you see here, that it leaves 3 minutes past 11 in this case, and 18 minutes past 11. So this is the way it works. And it's done within the Netherlands. So, but you also have short-term planning. Works on tracks can be put in months beforehand, so not half a year, but months. So timetables must adjust to that. And apart from that, you have also just operations. So delay can happen because somebody, for example, there was something within the train and it just got off 5 minutes too late. And you have people in the many people, just an army of planners within the entirety of Netherlands that are just handpicking trains between the different stations. And this is an example of that. So then to our field, or my field, simulation, I test the long-term planning through simulation. So no simulation is used for short-term planning or even for operations, only for long-term planning. And we do that with the 3 input types that I just mentioned. So the trains, the infrastructure, and the timetable requests. We do that and to put it into simulation. And then we have some output to check if that timetable is feasible. And if you see this graph, there's, I think, a very big improvement that can be made. And I think it's mainly because timetable is input. And I think it would be a good improvement if timetable is also output of the simulation. And that's currently also not the case. So it just provides is this timetable feasible or not. Current simulation does not provide, it does provide input for improvements, but it does not suggest improvements. So a big feedback loop of this system can be a big improvement. One more, this is the way we do it. So we have the entirety of the infrastructure within a simulation model. It can be called a digital twin. And every point in the infrastructure is put in. So it's a very, very big mountain of data, the infrastructure within our model. but also the timetable for each train course. We have arrival, departure, and all kinds of information necessary that we have agreed upon as stakeholders that provide a feasible timetable. So here you see a single station, which is not even a very big station, just has 3 platforms, Gouda. And you see that every train, as I just mentioned, you see here the green and the red lines are just for the signaling technicalities. Then we have also part of the simulation where it runs high speed, low speed. And together we agree upon some planning norms. So as input for the data, and that wouldn't be necessary if you have a feedback loop within the system. And it runs, currently we have just agreed upon that every train runs on 94% of its performance. So it can, in real life, can drive 100% of performance, of course. But then we together as Dutch, from the Dutch infrastructure manager and operators, we have agreed upon 94% and 60% buffer. So for example, you have here 2 trains. So the right train must go to the second platform, and we have 60 seconds of buffer before the other train can depart again. It's currently very simple, but with a mountain of data. And then some final remarks, and also back to, I think, the different rolling stock types. I think currently how we done it is we have provided some supply of trains, but I think it can be also optimized if we go to reacting on demand. That's currently not done, and it is actually done within freight, of course. The train only departs if it's full, so it reacts on demand. And that's also why it's difficult to plan freight trains. So we try to hope for a match between supply and demand, but we also want to have a reliable, regular transport. So if we go to a single train 4 trains every hour, we must keep 4 trains every hour, because otherwise passengers don't know when the train is leaving. Actually, there is a goal within the Dutch country that we want, so-called spoorboekloos rijden, it's called. So without a timetable, just go to a single track, go to your station, and then every 10 minutes there is a train. We want to reach that for the most important corridors, and we already have that. And there's also a difficulty in connecting to local transport. So buses, trams, metro. That's also part of timetabling. And I think this is for the first part of this workshop. And now we're going to have for some interaction. And it's already 2:15, but I think we can have possibly the second part a bit shorter. So have a break of 5 minutes. And then again to go to Miro for your view of computational design within railway engineering. All right, see you back in 5 minutes. 10 minutes before.
Oh, 10 to 2. Yeah.
Yeah, and I will post the Miro board again. Yes.
Okay. See you in a moment.
Yes.
Gijsbert, I'll just pause the recording here.
Mm-hmm. All right. So let us think about applications for computational design. As a result,
So Gijsbert, you can use the green or the yellow, yeah, doesn't matter.
It does not matter.
Okay.
All right. Does somebody want to describe what they have put in? I will share again the Miro board in the chat. So let's have a discussion. Is there somebody that thinks that they have a good application for computational design?
I was thinking, I wrote a very vague one there saying pattern recognition of session blocks, because they look like patterns that somehow can be automated. Yeah, I suggested that. So I don't know how much this is automated in the software, and yeah, so I wrote that other stick there saying what can be automated. You said there are lots of manual work, so I think there are lots of things that have to be put together by hand, right? It's almost like drawing something in CAD. You need to actually do it manually, and I was just thinking what can be automated. Yeah.
Yeah, good point.
So I was fortunate to do some timetable simulation training last week using some software. And when you put in an infrastructure, describing the infrastructure you need to use for the trains, you need to actually draw it manually, as in line, you know, so you have the nodes, the lines, etc. I was just wondering if there are things we can learn from BIM, for example.
Yeah, good point. Good point. That's actually true. So we have here a whole team currently working on updating the current infrastructure of the Netherlands. And it can be just a one-man job for the whole week, again and again, every week. So that's true. And we're currently trying to automate that by having digital infrastructure. That's true. Yeah. I see live data from users, but also live tracking of trains, adjusting the timetable based on big data, optimizing routes. Yeah. Another person want to give some information about what they have written down.
Maybe just yeah, the idea of tracking and speed as well. I wondered if there wouldn't be a way to use some kind of solvers and you know, to understand, okay, where is the train, how far is it from the destination, how many trains are on the lines, on the tracks at the same time, how do I prioritize the trains to make sure it goes fluid, you know, as freely as possible, as smoothly as possible. So using all sorts of sensors probably could feed the data for that. You could probably track the train speed anyway already on some of those machines. I'm sure it's available. But it's either feeding the information to I mean, as a live feed to the driver to say, hey, slow down a bit or do this a bit, but you know, almost in real time to say, if you slow down a bit now, you're going to go through much more easily, as opposed to just giving a red light and say, you know, wherever the red lights are. So it's something that's constantly feeding into the person driving. I think that would probably help a lot.
Yeah.
Yeah.
Very good point. Yeah. I will go into that later on. So I think for now, is there anyone else? Then keep these applications in mind. and then we follow up with the presentation. You see all my presentation again, yeah. So there are some challenges. So I think all of your input is very good, and is, I think, very important and can be improvement of the railways, especially now for I think a lot of demand for train use for passengers or freight is going to, but there are some challenges. And I think the first one, and I think the biggest one, is there are very high safety standards within the Netherlands, and I think around the world that's the case, because the way railways is organized most of the time, I think they are most of the time done by governmental bodies, and that makes it that a very high safety standards are applicable. So while Tesla, for example, has already automated cars, very complicated systems in place. Trains, there are 2 examples in the entirety of the world of automated trains. There are, in fact, very many examples of metro types, automated metros, but within trains, within the Dutch railway network is different. And that's also because of the complexity of the network, multiple different types of trains, different type of rolling stock I just mentioned. But also this is a very interesting graph, and it shows all the different types of components that are part of the safety system within the Netherlands in this case, but it's similar to other countries within Europe. And you see all the purple dotted blocks, they are safety components, vital safety components. And those have SAIL 4 clarification. So that means that it's the highest reliability safety requirements that currently are there in legislation. So, and then the tracking of trains, the position of trains is also, there are already somewhat of a component available on the market, not on the market, but there is somewhat of a abstract sense of how to do that. But it also requires a very high safety standard. So that's why it's not realized yet. But within railways, a very high accuracy is needed, very high reliability, and very high availability. And that's why it's very conservative towards computational design. And it's also the case within timetable engineering. So that is why, and I think this is a wrong point, but this is why a lot of human work is actually within the process. And I think you would say that a computer made less mistakes than a person does. But this is very difficult within the railway sector. So for example, if we want to change, or for example, automate operations of a train, then the train driver, who is not part of the safety system currently, leaves and is replaced with an automated system. Very high safety standards is set up on that system. So safety is a very big challenge. Are there any questions on that?
Yes, I have a question, as always.
Yeah.
What makes people think, or whoever set up the safety criteria, what make them think that having a person conducting the train is any safer than having a computer system?
Good
Where
point.
is the evidence for that? Or is it tradition, is habit, because we had it, we'll just carry on having it because we had it before?
I think there's no evidence vice versa. So there's no evidence that it's safer now, currently within railways. So there are a big thing for a train driver is that it can react on disruptions. And I think that's the main point. So if a situation does appear where, which is unknown for a system. So currently, the current system in place, which you also see on screen now, is a system that breaks for you. So if you ride through a red signal, the system breaks for you. So there is a system in place that actually does provide safety within the railways. But the train driver is mainly as a function within just travel in an ecological sense. So, for example, if a train is early, then it can go as well as you're doing within a car. You can just let go of gas and then just keep on the velocity you already have, and that's more ecological driving. But also a very important function is in case of disruptions, what happens. So then a train driver can operate it manually and drive on site, it's called. It won't go faster than 40 kilometers an hour. And I think there's currently no evidence that reliable evidence, and I think that a system could replace that. And I think there is currently some evidence from other type of sectors, but within railways it's difficult.
Yeah, that was going to be my comment on your answer, Gijsbert, is because we see, for example, in self-driving cars, the evidence now is that the AI, used for self-driving and real-time analytics for self-driving cars, it's becoming better than the average driver. So that is a case study that can inform the decisions made on safety in rail, because there is a precedent, there is a different industry, but there is a precedent that machine learning and AI can address similar situations.
I do actually think the same, in the same way, but it is a conservative sector. Yeah. And this is the case for the safety system, but this is also the case for timetable engineering. So if a computer sees clashes, human actions are needed to resolve these clashes, because not much the railway sector does not want to depend on artificial intelligence for that. So this is the case why the timetable is set up by people at the infrastructure manager, and then we test it again using simulation, but then again check the clashes that come out as a result of the simulation by hand, and check every clash and write on that in a report. And that's for safety purposes. Another point is adaptability. And I think this is an actual challenge for now, but currently these timetables are planned so in long-term planning, and that's mainly because on short-term planning you have planned disruptions. So in this graph, this is a very interesting graph. You see an overview of no train periods within 2022. So there are very many planned works on the railways in this year, and even for tracks that would because the works are there are no trains allowed. So, and here you have how many days, this is in Dutch, but I think it's easily translated, 6 days between these two cities, 12 days here, even 64 days between two cities, no trains, only buses. So how to work with that? I think now mainly surround to get the version, for example, for a train another way can be possible, but that's very difficult also with planned disruption, but also unplanned disruption. So this week was a case within the Netherlands, and now 3 days no train will go towards the Zeeland, the southern western part of the country, the entirety of Zeeland. So just because a bus went over here, and then so as a result, this is also a graph for this from today. On many places within the Netherlands, no trains can drive now. So how to work with that requires adaptability. The third challenge is there are, as I just told you, a lot of requirements of standardization, rostering, local safety, passenger freight requirements, but also stakeholder requirements in timetable design. So first, the requirement of having every hour the same. It's difficult to have that. The second one is if you change timetable, for instance, real-time timetabling, it can be possible. It can be possible within on the infrastructure with the current rolling stock types, and also within the timetable. But it might not be possible for a train driver that just want to have a cup of coffee and have its well-earned break, as well as if available trains are there and where they are currently. So if you want to have set up a certain train to a certain city, that space must be filled up with a type of rolling stock, which is then leave where it currently is and go to where it's going, and then how does it get out again? How does that work with rolling stock rostering, but also with people that control and manage traffic, and also for the train conductor. So each of them have rosters, and these requirements must be fulfilled. Another type of problem within timetable, real-time timetable changing, is that it has local impact on level crossings or bridges, especially for level crossings. That's a safety impact, especially if the crossing is at the same level as the road. If you, for example, have a closed level crossing for more than 5 minutes, or a level crossing opens after a train has passed and then closes very short after after a very short while, people have a tendency to just run the lights. So that is actually part of timetable design currently. And you have all kinds of level crossings, but also bridges within the Netherlands. So this is a complication. So you have passenger and freight. They require reliable transport. So for example, if you close down a certain track because of disruption, you must in some way have passengers and freight go from A to B. But then stakeholder requirements. And I'm curious again, just as a similar question to the rolling stock types, what is their interest? What is interest of these stakeholders? Can you put something in the chat of the different people, of the different stakeholders? What is their interest? What did they want? Just some thoughts. Good point. The most important point, I think. Arrive on time. Yeah. Good point also. Yeah. True. Also true. Well invested. efficiency and make money, true. Most of the passenger operators, they have a contract within the for the ministry to have reliable services, and they are evaluated on that money-wise. Local government, passengers arriving on time. Local government be connected to other urban centers. Nobody wants accidents, true. So these are all very important points. And I think for timetable design, each of them has their impact. For instance, if you have the train from Amsterdam to Paris, it takes 3 hours. And if you take the train from Amsterdam to Berlin, it takes 9 hours. That's a big problem. And one of the causes of that problem is that if you go from Amsterdam to Paris with train, it arrives and departs from Amsterdam, Rotterdam, Antwerp, Brussels, and then Paris. And if it goes from Amsterdam to Berlin, it goes to small villages, very small villages, which I think there are 10 plus stops where the train arrives and departs again, which takes a lot of time. And those are all local governments. So this is a point. The Dutch railways, they want to have intercities that are really fast to the entirety of the Netherlands, but local governments, they vote on it and they just want to have an intercity on their station. And I think every local government wants that, to have the intercity goes to their station. But if every intercity does that, all trains are just sprinters in our case. So it does not work. All right, follow up. And then I think also a problem is that the railways, Abel, you have a question or?
Yes, I do. So when you said the intercities and connectivity and the example Berlin, Amsterdam, Paris, is there an option to go to Berlin quicker, or do we have to stop, be like a drop in every single little town?
It can be quicker, especially if you it can be a lot quicker, especially if you don't stop at each town. And that makes also that you can be in high speed all the time. So you don't have to brake and you don't have to start up again.
Yes, but do you have that service? Do you have like an express to Berlin and then you have the normal service to Berlin? I'm sure it could be quicker, but do they have, so can you get a slow train to Paris and a fast train to Paris, or yeah?
It can. You can actually implement that, but it can be also a question. For instance, you have transport hubs. Transport is somewhat organized, is that you go to, so I think I do have actually. So if I check the Dutch network, right? This is the Dutch network. I think this graph is more clear. If I, for example, want to go to, from Zwolle, I want to go to Dordrecht, I go a very fast train towards Rotterdam and then go a smaller train towards Dordrecht. So I think an express train to Berlin is, I think, a faster train is, I think, is very nice to have. But why would you want to have a sprinter that goes to Berlin? I think it would be better if you just have, and it also increases capacity and speed and reliability of the timetable. If you follow up using slower trains on site. So have a few stations that are main hubs within the area. Use the capacity in such a way that then you can reach high speed, but also have fast travel time. So I would suggest such an approach. And I think that's a common approach, however, very difficult with local governments who has their own interest, of course. So then you have the railways is part of the system of systems. So hardware and software is very different, lots of different parts, components, changing software and hardware, of course. It differs per operator, but you also have international transport. And I think this is a very challenge for computational design, is that each there are lots of different systems, each of with their own impact on the timetable, which changes over the course of time. So as I said earlier, there can be just one person just working all the time on updating the Dutch railway network, because there are some changes to switches, or there's a second rail built, or there's different signaling, or there's the different catenary system, and it changes all the time. So as I showed you in one graph earlier, a lot of work has been done on the railway infrastructure, but also on ICT systems. And that's especially the case because every operator has a different planning system. So there's no single source of truth. And it's also been split up between planning system, which is a different system than traffic management system, which is a different system than the operating system. There are, which are connected, but not in such a way that they communicate easily back and forth. And also the biggest operator within the Netherlands is Dutch Railways. But recently the European Union has a new law in place that this is that they must be open for concession, the concession must be open for all types of operators. So we Dutch Railways can be removed in 2025, for example, or 2035, and then DB Cargo DB can take its place, for example. And that must be the case due to legislation from the European Union. So, and then planning systems are all over the place, because also the international systems each have their own infrastructure, their own signaling systems, their own catenary systems, and especially their own traffic management and planning and operational systems. Each with their own language. The common language within Dutch, within Holland is Dutch for these kinds of systems. So if a operational person, a signaler, calls the train driver, is just Dutch, and it's German within Germany, French within France. So that's just the case, and also a very big challenge. And then I'm very curious, but first have a break, but I'm very curious in how do you suggest, you just picked out some applications for computational designs within railways, but what are solutions to these challenges? So summary, high safety standards, very high safety standards, a very high need for adaptability due to planned and unplanned disruption. You have loads and loads of different requirements, local, but also country-wise, rostering, standardization. But you also have that it's part of many, many, many systems. So first have a break until 5 past. We skipped the last break until 5 past, 35 past, in my case 3, but in your case 2:35. And then, but think about what are solutions to these challenges. And I will copy paste them within Miro. And I will again share the Miro board. So I see you back in 9 minutes. All right, let us again look into the solutions for these challenges. What can computational design provide, in this case, the Dutch railway sector? Are there any questions? Well, possibly not all of the people are back again.
A couple of new people online, and
Yep, I saw it.
and when you say computational design, Gijsbert, you mean computational design applications that we can maybe transfer from other industries, or it's a plain automation of the things that can be automated?
Both. I'm very curious in what you each have your own background, which you specified at the starting slide. So from that background, yeah.
Okay, so I will populate based on my knowledge of BIM, for example. Yeah.
Yes. So I'm curious if everybody is back from the break. I think not yet. So, but people can fill in their solutions possibly. And then we can have a short discussion about it. So the first challenge is a very high safety standard. The challenge 2 is adaptability. Challenge 3 is requirements. Many requirements, local, but also from a governmental perspective. And then the 4th is the loads of different systems. All right. Let's review. Is there anybody that wants to go into depth of their solution for one of these challenges or has questions? I think a big thing for safety, as shown, is to the demonstration and a way to gain trust. I think that's actually a big thing. So for automation, for example, of operations, there are 4 levels of automation, and only the 4th one is actually with no train driver in the train, and the other 3 are. So hybrid solutions. And that can also be the case for timetable engineering. For adaptability, flexible and upgradable real-time analytics could be used to inform decision-making real time. Question on the latter one, real-time analytics could be used to inform decision-making in real time. And then eventually not inform, but also adapt. I'm not sure who has written that down. Is it only to inform?
Yeah, it would mean also to adapt. I mean, to make that decision making based on the unexpected problems.
Yeah. I think that's a good point, especially at the start. Requirements. Yeah. I think that's important to set for all stakeholders to be set requirements that can be fed in the process and equations. And I think that's currently also a big problem because you have many different stakeholders, each with their own input, and stick to it. Also very important because now you have many stakeholders that just depict a very qualitative requirement. And it's, I'm not sure, I think it's a hobby of all the stakeholders in there, but it's really difficult to fulfill these requirements. There's something within railways, especially for safety reasons, as low as reasonably practical. So that's as a thing, but what does it mean? Nobody knows. Then systems, standardization, but also standardization across operators and countries. We try to do that. However, it's very difficult to align stakeholders on this. And establish common data environments. Yes, very true. And international digital object and asset library. Yeah, true. Also very difficult because the start data, the infrastructure starting data, signaling, catenary systems, but also railway construction are very country dependent. So every country has its own set of rules. Every country has its own set of specifications used in design. So design guidelines, each of them are different. They are based on European legislation, but that is very high level legislation. We have 10 minutes left. I'm really curious on things you have learned or questions you may have. I think the next workshop will start already in 10 minutes. So are there any questions or remarks or learned things that you have learned?
I think it's interesting to see that it's not just the UK. It's having trouble with their trains.
Yep.
It's nice to see the complexity of it. Very, how it's laid out. The various maps and diagrams that you displayed was quite interesting. Yeah, very good. Thank you.
Right. Thanks for the comment. Carlos?
Yeah, first of all, I enjoyed your presentation and the workshop. Very informative. My comment after learning a bit about that is that maybe we have the technological potential to do much more, and it's actually the cultural things and the lack of integration of systems what hinder the progress to do more. And this is my impression.
True. That's actually, yeah, that's very true. Yep. Thanks. Abel or Victor?
Hello. Yeah, it's interesting to see. I live in Germany, and I feel that every time the delays are getting worse. And now I will not only complain about the privatization of the train company, but I understand that it's a lot more complicated challenge. But I also see that there's a lot of opportunity for application from the knowledge of computational design to improve the efficiency of the service.
Mm-hmm. True. Yeah, everybody that works on computational design, they can get loads and loads of jobs here within the railway industry. Yeah. Right?
Yeah, I mean, what I would say is it seems that that the railway industry has adopted digital tools quite early, I think, like a digital timetables and to an extent CAD systems, but that is now has a legacy and people don't want to change tools or don't want to innovate in the tools they have. I think because of the high risk of getting things wrong or changing systems. I think in the railways industry, there is that thinking that if it's not broken, don't touch it. So if it's working, just leave it. But I think there is quite a lot we can learn from BIM data management and BIM processes and how to federate data in collaborative endeavors, collaborative projects, and how to make them more parametric. I think all of that can be adopted by timetable and rail simulation. It's quite impressive that even in the UK, we don't have a national, an effective and accurate national timetable. So Network Rail has a national timetable, but they don't guarantee accuracy. They just gave me a copy and I'm playing with that. But they say we don't guarantee any accuracy because lots of people are working on this. And the software itself does not allow for effective collaborative development of this national timetable. So as you know, Railsys does not allow for that. You need to create subsystems, right, or subnetworks, and then copy and paste things and do things like that. So it's nothing like a BIM collaboration platform where you can do more sophisticated things. Of course, you have the online collaborative version of Railsys, but it is very expensive and training is hard to get and all that.
Yeah, but so, I think that the technicalities are there. And I think that what Carlos mentioned, I think this is, we just have, if everybody get into their own role within the system, then we would actually work towards a very good transportation network. And I think this is like the bigger goal, right? And this is why I was very enthusiastic when Abel asked me to do this workshop, is that we are currently, we're trying to improve the railway network, also as competition for flying, for airline industry. And I think with this, all the problems and challenges we have, I think that it would benefit greatly from things like computational design, automation. So yeah, I'm really, so thanks for being here. And thank you all for your input, and I will put them to good use. And if you ever want to do a job here, send me an email.
Great,
Thanks.
Thank you. That was very interesting.